Hello, my name is Rich Howard, owner of Architectural Builders Supply. This video is to bring you a closer look at the Dorma CP660. This is a center hung pivot, is what it is. CP center pivot. 660 is a reference to the weight rating of the door that this is engineered to handle. And we'll do a quick visual tour of all of the parts. We will do a quick dimensional tour. 660, CP660, AMS 626. I'm pretty sure the AMS is going to stand for all machine screws. I don't know that because there are fasteners here to work in a wood application as well. So AMS, I would know that to mean all machine screws. I don't. If it means something else to Dorma, I'm not aware of what it is. So at least not at this time. The floor portion, the width of the body itself, it's about 4 3/4. The depth of the body, or the width, about 5 1/16. Its overall height, just to give it some scale, I suppose. Looks like it's about 2 5/8 or so. Your spindle's going to sit right inside of here. I happen to have the spindle here. There are different spindles available with the Dorma system. Okay, this is what I mean to say is there's only one spindle. There are different lengths of these spindles, and we'll talk about why that's the case. That sits right in there. You're going to, and down the drain pipe it went. These are not screws that you can get at Home Depot. A shoulder bolt that will allow you to secure that down in there. Okay, an Allen wrench to tighten it down. You're going to get a collar and a washer that will sit over that spindle when it's there. You're going to, of course, get a faceplate. This is the 626 reference in the part number. Satin chrome. That's what that is. What this is going to look like. Now let's work our way up the door. The bottom arm. This, by the way, the floor component and the bottom arm, it's the same material that you're going to have in a CP1000. Okay. Just getting the camera to refocus there. So this is the bottom arm for the CP660 and the CP1000. Maybe others. I don't know that it is. I don't think it's the same arm on the CP440. We'll take a look. About 9 1/4 overall length. Its width is about 7/8. Its thickness over here is about 3/8. Down over here, it's about 3/4. Not necessarily anything that you have to know about that, but it's going to sit right like that. It's going to sit down into your floor bearing. Okay, continuing to work our way up the door. Here's your door component. That's going to go into the top of the door. This is going to go in the top of the door as well. And what is interesting about the top pivot from Dorma on the CP660 is that you can adjust that laterally by this side load screw that would be there. In the edge of your door, you'll certainly have to have a hole for that screw that's going to be in there. Okay, and that'll all get attached down once it's set. You'll have screws that will run through here, and you'll tighten those down once you get that set. I suppose it's nice to be able to adjust the door in terms of where it's sitting, but you're not changing the point down here at all. All you're doing is this. I suppose it's okay. The bottom line is when you install that top pivot up into the header and you drop your plumb bob down, you're centering right down the exact center of where your bottom spindle is going to sit, your spindle stud. To be able to adjust the top, you know, frames do have a tendency to become somewhat trapezoidal with time. I don't know how much effect that will actually have other than the ability to adjust it should you have a issue with your frame tipping a little bit. Now we're going to go up to the header. This is what's called a walking beam pivot. As you thread that bolt in or out is how you draw the top pin in or out. Okay, and you can probably understand that that's how you actually install the door. You have your cover plate here. So header portion goes in, plumb bob down, bottom floor portion gets set into concrete, in fact. We'll talk about that. You mortise the door top and bottom. You're in good shape when it comes to that. You take your door, you place it down onto the spindle, you tip it into place as the door is slightly ajar, and you draw the screw down to draw your pin down into the door portion. So it'll end up looking like that. Okay. After that, what we'll have remaining now is just a whole series of all your fasteners that you're going to need. That's that funny screw for the top pivot, for drawing that in and out in the top of the door. Other fasteners, that's the balance of all of the contents here. Okay, so let's now talk about exactly where you're going to use this piece of hardware. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Okay, so where are you going to use a CP660? Well, somewhere where you've got something awfully heavy, that's to be sure. And you'll very often find that clients are using pivots in applications that aren't always necessarily doors, or they may be doors, but they are usually unusual, typically unusual. Very common applications would be a bookcase. You know, a CP660 or a CP1000, you want a hidden bookcase. There is a gentleman, his name is Gary M. Katz, I think. Let me look at it. Yeah, okay. Yeah, okay. So if you were to search, his name is Gary, G-A-R-Y, Katz, K-A-T-Z, and if you were to search for that name in hidden pivot bookcase, you'll find an interesting installation where you will use a pivot rated for a great weight that is not a door. And this is a great example of that sort of application where he's built a bookcase and used, it wasn't a Dorma pivot, I think he used a Rixson 370. In fact, I can see that he did, is exactly what he used, rated for 500 pounds. So a bookcase would be an application. A false front, we did a job for a client where they had an entertainment center and a couple of architectural panels on either side of this 10-foot wide shelving. You know, it looked like it was all maple, 10 foot tall, a built-in. But one of those doors opened up to reveal a I think it was laundry. I think it was a laundry room. It wasn't a safe room or a safety room or something like that. But they needed a concealed way to go about making it less obvious that there was a door there. And there was actually maybe a touch latch application. I've also had people use pivots like this in wrought iron exterior gate work. You know, I've had people use center hung pivots when a client of ours did a real interesting one that they had. If you've ever gone into a fast food restaurant through the drive-through, you'll see that there's an area of dumpsters, of garbage cans, and they will shield that off by using a fence or some sort of architectural element. This client literally created something quite chic when it comes to concealing their garbage cans, and they used pivot hardware for that. Or it's just a door. It could be your run-of-the-mill 150-pound door, 200-pound door, 600-pound door, 700-pound door. Where would you get into these super heavy doors? Well, obviously larger doors, 4 foot by 9 foot. You could also have a lead line door. You could have something happening on the door that causes it to be much heavier. You could have an epically large door that's got a very big, thick piece of glass in it. It could be, you know, lead leaded type glass. So pivots, and it wouldn't be center hung generally, but very large weight capacities go along with very unusual applications. And this video is really just to give you some background of the CP660. Now, you'll notice that there are these weird silver things here. These lugs are here for a specific purpose. You should be able to turn those out if you want to. Now, the reason that they're there is because this pivot in the 660 weight range and the 1000 weight range are not engineered, designed, tested, intended to be screwed down to the floor. The logic, and I had asked the tech support department at a pivot manufacturer, why we wouldn't want to screw this down. It was a 1,000-pound pivot. It wasn't a CP1000, it was by another manufacturer. And the answer was, well, because those fasteners are not rated to handle a 1,000-pound door. They're just not. So the way that this is intended to go is that you're going to build a box in the floor, you're going to fill that with mortar, and you're going to set this in place. You are then going to brace this so that it cannot move and that it's level in every possible sort of degree. It's completely level. You might consider creating a contraption that can be screwed down to this unit, that when you push it down in place and your plumb bob and your spindle are right on the money, you'll then make sure that this sets in place, probably cures overnight, and that's how this is installed. Could you remove these lugs? You can. And screw that down? You can. It's not engineered or tested that way. But that's why these are there. There are no fasteners necessarily for this. There are no fasteners that will come with this for that intended purpose, even though there may be, but this is meant to go down into grout. If you install it to the floor in some other fashion, well, then there you go. But the way it's been designed at the factory, their instructions are going to call for it to be poured in grout or mortar. So we've talked about the different applications that you may see something like this in. The templating, the instructions, the product catalog we're going to go over next. We'll look at a series of photographs. Installing this material is it's conceptually very easy to do. When it comes to center hung pivots, you're generally going to have a radius on the edge of the door or a bull nose if it's single acting, because you're bringing that margin up quite close to the jamb, 1/8 of an inch. And if you have a square edge door and that door goes to pivot, if my knuckles are the outside corners of the door, I pivot that, I'm going to make contact. That's the idea, the concept. So plan on radiusing or bullnosing. Bullnose is the top row of tile in the bathroom. If you're just going to single act, you'll bullnose. If it's double acting, you're going to radius the whole style. If you can't radius the entire style, you're going to need to make an adjustment in your installation to give more room. And quite frankly, you may want to elicit the services of someone that you buy the pivot hardware from to throw this into AutoCAD and say, here's where your vertical axis of pivoting needs to be based on the door thickness and based on how you treat the edges. That's something that's a service that we can provide. So let's switch to the screen view and let's take a look at a large number of supporting documents. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. All right, let's take a look at some images that we have. The label. Everything that's in the box. The floor portion. These are the screws that hold the faceplate. The tapped holes, I should say. Another perspective on that. Showing the lugs. Other manufacturers will have these actually curved. I've had people, and that's for the obvious reason of increasing your surface area. Well, probably not increasing your surface area, but they're bent in irregular patterns in relationship to each other. So making it, I would think, more appropriate for literally pulling it out of the floor. I had a client of mine call one time and said, boy, this thing is all damaged on the bottom. And I said, what do you mean? He sent me photographs. I says, oh, no, you've got to read the instructions. That's the way it's supposed to be. Showing where the spindle will seat, that tapped hole with that shoulder bolt, the underside. Let's take a look at some more. the collar and the gasket that will sit underneath there, the screw to hold the spindle on, and the Allen wrench for that. The bottom arm, these are in no particular order, by the way. Another perspective on the arm. This is the face that touches the underside of the door. Profile, this is where the bottom pivot fits. The top pivot from the, like in a plan view, I suppose, looking down. The door portion, both of the door portions. The scalp plate or face plate for the top pivot, your fasteners, and your screw installation instructions. These images were out of sequence. There's your cover plate. There's the spindle and the associated parts. Some different perspectives on the spindle. And again, it's the height that's going to change. We're going to talk about that when we get to the product brochure. That's the underside of the spindle, shown again. Okay, that is all of the images that we have, but let's take a look now at installation instructions. The top pivot, the bottom arm, and okay, so let's go from the bottom up. It doesn't matter. We'll just start here. Okay. So this entire bottom portion can be used on center hung and offset hung pivot assemblies. What changes is the bottom arm, and one nice thing about the Dorma system is that it's quite modular. This component, the 7471 HD, is used in different systems, center hung and most definitely offset hung. So prepare floor according to template. Grout in, so the very second sentence tells you that this is grouted in place. Grout in floor, bearing with angles, and attach cover plate. Make sure spindle center line is in the proper alignment with top pivot. Bearing should be grouted in place so that it is square with frame, level in all directions, and the top cover plate will be flush with the finished floor. For threshold applications, drill an 1.25" diameter clearance hole in the threshold coinciding with the spindle location. Top of floor bearing cement case is flush with finished floor for threshold applications. Anchor floor bearing first, then the threshold, and then the threshold over it in the usual fashion. Attach the spindle with spindle screw using the included 5mm hex wrench. So what they're saying is, if you're going to drop this down into a bed of grout, the finish plate has to be flush with the floor, which is shown here. If you are going to put a threshold over this, the top of the body less the cover plate, you're going to have a cover plate and 4 screws left over, is then flush with the top of the finished floor, is what they're going for there. Now, they say bearing should be grouted in place so that it is square with the frame, level in all directions. Okay, so that's really the hard part. That's really what they're talking about there. So here's your spindle. So what they're saying is when you set that into, when you bring that and drop that in here, well, you get the concept. Okay, that's all going to be grout, all in there. So you need to make sure that it is level in every possible direction. And how you go about doing that obviously is not detailed in the instructions, but I would be real tempted. You've got those 4 holes. I would be tempted to make myself some sort of a structure that I could screw down to this that might be something like this. I'm just thinking out loud. I could screw that. Well, these could go way off. This could screw down. You could push all that down, and you can reuse this for another project. Now, if you wanted to get even lazier, which I fully endorse, you could create yourself something like this. And do that over here as well. So that you attach that down, and you are not only getting it tight on this corner, provided that the jam is true, you're positioning this accurately based on the cased opening frame, but you're also making sure that it's in the right orientation as well, that it's perpendicular basically to the cased opening frame. So some sort of tool to allow you to do this. I've not invented this idea. It exists, just not by Dorma that I'm aware of. So that's really going to be considered the hard part, I suppose. Of this type of project. You're going to have to create a box to pour that mortar into, or however you're doing it, wood floor or concrete floor. And then they go on to say, center line is in proper alignment with top pivot. So you're going to drop that top pivot. That plumb bob's got to come down, and it's got to hit right on the money of that spindle. Right on the money. You're going to need to concoct a way to get a plumb bob attached to the top pivot, which I do have a recommendation for that as well. We'll steal a quick look at the installation instructions for the top pin. Now, it's not really showing the pin that's coming down really well, but if you recall, that pin is going to drop. Oh, it is dropped down here, just not shown.
AEB supply.
Okay, so it's here. So what you could consider doing, and again, I've not invented this idea, you could get a sleeve of metal that has the proper ID to go over your spindle, which might be 1/2 inch in diameter. Except you're going to drill a smaller hole. Let's try that drawing again. Set screw. Your spindle will reside in this place, except in here, I've kind of screwed the drawing up a bit. You can drop your string for your plumb bob down, tie a knot in it here, and it will come right down here. Okay, you might be able to do something like that to make sure that you're spotting it correctly. So that entire first paragraph is really everything that you need to know. Technical drawing showing all the dimensions of everything. Stuff that's absolutely good to know. Nothing that you and I don't think need to go over. And what I'm saying here is I don't see anything in particular that needs to be called out that we've not already talked about. They do show a radius here, even though they don't define what it is. That's generally just not an eased edge. That's actually usually a radius that's here. Because when that door comes to rotate out, and that's a good application of AutoCAD as well, you want to make sure that it's not going to hit the face of the stop. They should call that radius. It's small. It's like 3/16. It's a very, well, that's large, but there is a radius there, is what that is. You could find that it hits, and if you do, you'll have to break that heavily or radius it. Showing you, so this is important. Actually, they're both very important, because what they're giving us here is the center line of the pivot for an offset application at 13/16 from the jamb. It's 3/4 or 1.5 offset from the face of the door to that dimension. So now you know where to place that, locate that. I shouldn't have said there was nothing on there. Same thing with an 1.5 offset, and then your center hung. 2 3/4 from the cased opening frame, generally centered in the jamb itself. I don't see why it would need to be necessarily, but generally you're going to position the door in the center, but you don't have to. You could bias that if you wanted to have, if you were doing a flooring condition, you could set this such that the face of the door, there was no inset. And let's say you were doing a terrazzo application. You'd literally have to have a sheet metal pan to fit over this, prepped for the spindle to come through. And that leads us to the next thing, a longer length spindle. So you could conceal all that hardware, and that is, in effect, a lot of the time that you're going to see people specifying center hung pivots. They want the hardware concealed. So this shows you where to stick all that, to place that, I should say. Okay, so now we're going to get into the entire installation instructions. Let's go to, now these are the bottom arm installation instructions, and then the top pivot are the third ones. Yeah, well, let's just go through it. You're going to mortise the bottom of your door and attach the door using the screws appropriate for your application. You're obviously going to mortise that such that your positioning is completely in alignment with where you're going to place the door onto the pivot. Same concept with the top pivot, frame, header, and door assembly, and we'll get to those dimensional drawings in a moment. Heavy-duty center-hung top pivot. This is not for this hardware. This would be for a CP1000. The CP660 uses this assembly here. Now, let's take a look at the bottom arm, and what they give us here are dimensional properties, telling us where things need to be placed. So you know the jamb to this center line, which will then allow you to deduct from, I think, 2 3/4, the 1/8 of an inch, to the edge of the door. Now you're at 2 5/8 to here. You're going to deduct 1 3/8, so that's going to be 1 1/4. No, 1 3/8, right? 2 and 5, yeah, 1 1/4. 2 5/8 minus 1 3/8 is 1 1/4 to here. Then you know the length of the arm, 7 7/8. You know the 15/16 width. The depth is right here. Mortise depth with a little asterisk. And it's always the asterisks that you need to look for. Now, this is where the longer spindles come into play. Because with the standard spindle, it's going to allow you a clearance of 3/4 inch, which means your mortise depth is going to be 23 30 From the bottom of the door to how deep you mortise that with your router is 23 30. It's basically just a long rectangle that's been prepped in the bottom of the wood door. Well, let's say your clearance, well, okay, let's define that term, clearance. So clearance is, there are two terms to be aware of. There's undercut and clearance. This is a hollow metal door and a hollow metal frame. Well, it'd actually go like this. Undercut is the dimension from the bottom of the door to the, the bottom of the door to the bottom of the jamb. All right, we're talking about clearance and undercut. So undercut is the bottom of the door to the bottom of the jamb. On a hollow metal door and frame, it's typically 3/4 inch. Okay, could be less, it could be more too, but standard is 3/4 inch. Into that space, you've got room to stick a threshold generally. However, that's undercut. Clearance, though, is the dimension from the bottom of the door to the finished floor. So clearance is what we're talking about here, not undercut. And they're saying here that your clearance There's a chart here for clearance. Now let's say that you were only going to be contending with 3/8 clearance. Well, if you're going to have less clearance, bring that door down, what are you going to have to do to the mortise depth? Well, you're going to have to increase it correspondingly, which is okay. You can do that. Not a problem. So if you had 3/8 clearance, you'll add 3/8 to your mortise depth, because the relationship between top of the finished floor to the top of the arm is a fixed relationship of variable x and variable y. If this goes down, this has to go up. If this goes up, this has to go down. When you're dealing with a single length type spindle. Now, that situation where you've got an unusual spindle length, what's happening here is you can increase your clearance and keep your mortise depth consistent, but what's changing is the length of the spindle. Standard to whatever that is, to 5 all the way through to 50 millimeter. Okay, so that's how they're contending with that. Now, where would you use those longer spindles? Lots of places, as I had kind of led to or touched on earlier. You could have a condition where this is your jamb, this is your door. The hardware is going to get installed cased opening frame, door. Okay. That pivot hardware is going to get dropped down into the floor. But we know that they're going to pour a floor. They're going to add carpet. They're going to do hardwood. That's going to be terrazzo. So what you need to do is you need a longer spindle is all you need. And that's where those extended spindle lengths. So it's really there to account for the flooring condition as that's going to evolve and change. It's going to account for the flooring condition based on the application that you're contending with. And at the end of the day, it's really not that big of a deal. And I'll show you in the catalog where those other spindle lengths are listed. So now you know where to place this from the jamb. You know how deep to make it, and all of its dimensional properties. Let's slide over to the information for the top pivot. This is the one for the CP660. And the next document after this is just simply the product brochure. So your header portion, that's your walking beam. It's a walking beam because this pivot adjustment, as you thread it up or down, is going to force the pivot pin up or down. Okay, pretty simple and straightforward. Scalp plate or cover plate, your door portion, you'll install that just like they show here. And you're not going to complete your installation. You're gonna get the pivot channel installed into the door. You're gonna get it secured down. You're gonna put that set screw through there into here, but not tight. That pivot channel adjustment screw will go in, and once you've got the door plumb square to the frame, by adjusting the pivot channel, you'll then tighten that set screw. And I'll leave it to you to walk through these steps. Dimensional properties of all of the hardware, pretty simple and straightforward. One way or another, you're going to be able to derive an overall length on this. Well, I'm probably going to go with 6.5 by 1 inch, and then it gives you the depth here of 1 3/8 inches. Gives you your door portion as well, 7/16. But they're not giving us the length. We need to know the length to do that. Here it is, I think. Yep, here it is. Yeah, 3.5 plus 1 9/32 is your length, 1 5/32. Now, it goes without saying that this pivot channel adjustment screw, you're going to have access to that. And that's shown here. It's shown obviously in a radius edge aluminum door. But if it's a wood door, yeah, you're going to need to drill a hole in the edge of the door. assuming you're going to use that adjustability, which, you know, I would absolutely install that screw, because otherwise you've got just this one component that's holding the entire door in place. So yeah, you're going to need to drill a hole in the edge of the door for that. Now, very interesting, they're showing you a radius of 2 5/8. That's the radius that they want to see on this. Or I should say, it's probably going to say something to the effect of, it can't be greater than 2 5/8, because otherwise the door won't be radiused sharply enough. 1/8 of an inch margin. If you were to need a 1/4 inch here, pardon me, if you were to leave this door square edge, you'll just have to increase that 1/8 of an inch slightly. Not very much. I put that in AutoCAD. It probably wouldn't need to go to much more than 3/16. Now you know how to mortise the door completely. Okay, now below this video is a link to the manufacturer's page, and it's going to look just like this, more from Dorma. And when you click on that, you're going to be able to pull up not only all of the Dorma products that we sell by means of this horizontal navigation, but also a link to the manufacturer's website, pardon me, the website, and the full product catalog, along with other encyclopedic documents here as well. So let's click on the full product catalog, Dorma product catalog. And this product brochure that I'm about to scroll to is absolutely, there's a link to it below this video as well. So the CP660, here's our product brochure, the LM series pivots. This is all of the offset pivots, center hung pivots, and what you're going to have is this product brochure. Also, there will be a cross-reference chart from Dorma to Rixson. Along with there being an overview of the pivots. So there's a cross-reference chart. There is also a quick and easy chart here for door weights, center and offset. You would never use a center hung pivot on a fire door. You won't. They don't exist. This applications page showing center hung and offset hung is really important. There are center hung, 3/4 offset, 1.5 offset, and then pocket pivot hinges, or what are also known as Harmon hinges. We won't go into that here. Pivot selection guide is here. So where are we starting? How heavy is your door? Are you doing offset or center hung? Then you can get there. If you've got a 5-foot wide door, technically the CP660 is not going to work. It may work, but you're going to want the CP1000 because that's how it's been engineered. 5-foot wide center hung doors are very common on the West Coast. Now, one thing that I like about Dorma is they get into drawings that show a breakout of all of these pieces of hardware in different door applications. So the CP440, that's going to be for an aluminum storefront application, whereas the CP440 could be hollow metal and wood. The bottom arm is going to be different on aluminum versus wood, where you get that ability to adjust that laterally as well. Now we're at the CP660 and the CP1000. The only difference here is the top pivot. The HD 8060 is the top pivot on the CP1000. You can see here, as referenced in your drawing, that's the CP660 and there's the 1000. That's the only difference. Those drawings are really nice to be able to have. It allows you to just look at graphically what you're dealing with and then select the right part number. We're also going to take note of the 7147 HD. That's our standard bottom pivot on our CP660. Let's take a look at a fire-rated 750-pound offset pivot. It's got the same floor bearing. Modular system, you're swapping out the arm in that regard. And obviously the rest of the hardware. 1.5 offset, some technical drawings for your review. 2 5/8 radius, you'll have to radius the door. or leave it square edge, but you'll have to account for that if you're leaving it square edge. Radiusing the door is not a big deal. You're just going to need a very large round over bit. Put it into a router that's probably a horse and a half with a modified base so that you can stick a giant round over bit down through it. Top pivots, intermediate pivots for offsets. I'm scrolling because I want to get to the... Here we go. These are the part numbers for the interchangeable spindles. So the 74005 is your standard. What's interesting is they don't list that 74003 spindle extension, but they're telling us clearance is determined by mortise depth of arm, which I led into earlier. You know, you want a shallower clearance, you're going to need to contend with a deeper mortise. But if you know that you're dealing with a 1 3/8 clearance, this is the spindle part number that you'll need to specify in lieu of the standard 74005. And that's the important part of this. So you not only have the type of pivot, center or offset, you've got the weight rating, whether or not it's fire rated. You've got the width of the door to think about. And then you've got your, before you get to finish, you've got to think about your spindle extension. What clearance are you working on or working with for that opening? Now the specifications that are up in the beginning of the product catalog, we can briefly go through that. LM series pivots are made of brass and stainless for rated and non-rated doors. High traffic interior and exterior, extra heavy doors, lead line doors, 20-minute and 3-hour ratings on offsets. You can handle doors up to 1,000 pounds. The center hung and offset pivots are defined here, which if you're not familiar with those, everything that you ever need to know about the difference is this. Here's 30 years of hardware experience. Center hung is when the vertical axis of pivoting is down in the center of the thickness of the door. Offset hung is when that same vertical axis of pivoting is either 3/4 inch off the face of the door or 1.5 inches. Why would you want 1.5 inches? You might have a clearance condition to get around. You might have chair rail that's been nailed to the bottom, to the face of the door, or maybe some sort of other architectural millwork. You might have an unusually thick door. You might have a door that's 2.5 inch thick, and you're going to use an offset pivot like this to account for that because you want the arm more centered in it, but the proper way to do that is you order the pivot based on the door thickness. I've used it in all of those applications. Finishes, plated finishes, prime coat, bright brass, satin brass, polished bronze, satin bronze, oil rub bronze, polished nickel, satin nickel, polished chrome, satin chrome, sprayed finishes, aluminum, dull, medium and dark bronze, gold and black. That covers all of this documentation. Let's wrap up this video on camera. If you've made it this far into this video, you must be determined to see it through to the end, and we appreciate your hanging in there with us and watching this entire video. It means a lot. It takes a lot of work to create these videos in the sense that, you know, it's time taken away from doing other things. However, the advantage for me personally of creating these videos is the fact that it does allow myself to either learn about something new, to reacquaint myself with something, or to reinforce what I believe that I already know. Any comments that you might leave down below would be greatly appreciated. Thank you. So I hope this video has been some assistance in helping you understand what the CP660 is. If you have any questions on this hardware or any other Dorma product, please feel free to reach out to us. Pivots, every once in a while, anyone who's in construction will eventually bump into a pivot. And those that are in construction and deal with pivots are eventually going to deal with a really unusual application. And pivots do a great job at helping contend with unusual requests in terms of what we're doing. Bookcases are very common, and that Gary Katz article is interesting. And it all boils down to where is that vertical axis of pivoting? And the use of AutoCAD is something that I can do to provide you with a clear guidance in terms of here's where that bottom pivot needs to be based on what's happening on the door itself, what's happening in the frame, what's happening on the face of the wall, what's happening to the face of the door, depending on the degree of opening. I've had customers that really wanted to do, there was a wall with a pair of doors, and there was a perpendicular wall about 8 inches over, and the client wanted that one door, they wanted both doors, the left-hand reverse door to go to 180, no problem, but the right-hand reverse door to go to 180, but actually 270 degrees, so it folded all the way back on the face of that perpendicular wall. No problem, but the use of AutoCAD allowed me to render plane for all to see exactly what that hinge would have to look like in order to account for that. And it just became quite obvious that custom manufacturing this very unusual hinge, because of where that vertical axis of pivot had to be way off to get the door from 0 to 90 to 180 to 270, and that was the trick. So AutoCAD is a service that we can provide when you're buying pivots from us and you need some guidance in terms of where to locate that material. Any questions on the CP660 or any other Dorma product, please feel free to reach out to us. And thank you. Again, thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you. Thanks to our clients, Architectural Builder Supply is building an additional facility, and what follows is not only a look at the acreage that we're building the facility on, but also first the architectural renderings as they exist, or at least the architectural plans as they exist at this time. Thank you very much. Let's take a look. All right, let's take a look at the architecturals as they exist at this moment, or at least it wouldn't be proper to call these architecturals, but it would be proper to call them renderings in the sense of they're conceptual drawings, they're not renderings. So the entire space is going to look like this in terms of a site rendering. This will be a 22,000 square foot building, of which we'll have specific purpose areas. There'll be a workshop down here. This is a few thousand square feet that will be likely woodworking, metalworking, CNC, things of that nature. This will be an office area here, a private office area. This will be Architectural Builders Supply expanded storage area where we will be able to do fulfillment. The entire space in the center is going to be all of the volume, as I call it. Large components will be able to be stored and stocked there. Machinery that's too large to fit otherwise may be put out here. Specific facility rooms, and then some recreation over here. Let's take a look at that drone footage, and thank you very much for taking a look.